All right, well, let's do 5A as long as we're doing B and C. Part A says, determine the vertex. How do you look at this data that's given to you and determine where the vertex is? A vertex is either the lowest or the highest point. So what I see is my data is coming down, gets to a low point, and then it turns around and starts to go back up. So I think right here is the vertex. Looks like my lowest data point. So it looks like this parabola is coming down, back up. So it says years since 1990. So that would be 8 years, comma, 297. There would be my vertex. What does that vertex mean?
In 1998, U.S. defense spending was its lowest at $297 billion.
In 1998, spending was $297 billion. And you said something else very important, and this was the lowest amount ever.
We're saving taxpayers money.
Yeah, saving taxpayers money, I suppose. Okay, so back when we dealt with linear equations, quite often all you would tell me was in 1998 spending was $297 billion. When you're dealing with a parabola and you're finding the vertex, you should tell me more. You should tell me, and this was the lowest amount ever, or this was the highest amount ever, depending on if the vertex is a low point or a high point. Okay? All right, now it says, find a quadratic equation f of t in vertex form. Well, vertex form looks like this. We have the a, usually we use x, but we're going to use t here, t minus h squared plus k. Without doing any work at all, we need to find a, h, and k. Without doing any work at all, we should be able to fill in two of those letters.
H and K.
H and k. How can you fill in h and k? It's the vertex. So they're 8 and 297. H and k give us the vertex. Since the vertex was 8 to the right, we're going to plug in 8 right there. And since it's 297 up, we're going to plug in 297 right there. So we have f of t equals a times t minus 8 squared plus 297. How do we find the a number? Go ahead.
You can plug in another point.
You pick one of the other points, any one of them, it doesn't matter which one, and you plug it in. Now it does make somewhat of a difference. Depending on which point you pick, you will get a different a number. So if I use the 1992 380, I'll get one a number. If I use the 2007 572, I'll get a different a number. But they should be fairly close to each other. Now looking ahead, I see that it wants me to predict defense spending in 2014. Since it wants me to predict defense spending in 2014, I'm going to use the data point closest to 2014 because that will give me the most accurate answer when I go to find defense spending in 2014. So of my data points, which one is closest to the year 2014? 2007, 572. So what do I plug the 2007, where do I plug that in? Well, t in this case, we're not using x, we're using t. So if I'm going to use 2007, t is not 7, 17, because we started in 1990. So I'm going to plug 17 in for t, and I'm going to plug 572 in for f of t, for the y value. So I'm going to have 572 equals a times 17 minus 8 squared plus 297. All right, I got to do a little work now. What's 17 minus 8? 9. What's 9 squared? 81. So I'm going to write this as 572 equals 81a plus 297. and then I need to get the A all by itself. To get the A all by itself, I subtract 297. 572 minus 297. My calculator tells me that's 275 equals 81A. So A is 275 over 81. Ugly decimal. It doesn't reduce. I'm just going to leave it then. I would prefer to leave it as a fraction rather than put it as a decimal and round off. I'd rather have the fraction, which gives me the exact answer. All right, so the answer for part for part B is f of t is 275 over 81 times t minus 8 squared plus 297. That was the hard part. Once you get that part done, part C should be pretty easy. How do you find the defense spending in the year 2014? Well, that's a year. We started in 1990. How far away is 2014? 24 years. So we're going to plug in t equals 24. Answer is f at 24 is 275 over 81 times 24 minus 8 squared plus 297. I grabbed my calculator and I typed that up. And I get 1,166, rounding off to the nearest $1 billion. So last year, according to what we have here, we spent about $1,166 billion on defense spending. Sounds right? I honestly don't know. I have no idea how much we really spent on defense spending.
I'm sure it's a big number.
I'm sure it's a big number. Would I be terribly confident that that answer is correct? Probably not, because my data ended in 2007, predicting 7 years out. That's pretty far out of my data range. I would not be terribly confident that that number is accurate, but that's the number we get based on the information we have. Questions on that one? Other problems on this sheet you'd like to look at?